Welcome to tonight's video on verifying trigonometric identities and also solving trigonometric equations. First, we're going to make a list of the identities. The reciprocal identities, like the sine is equal to 1 over cosecant. Cosecant is equal to 1 over sine. Cosine is equal to 1 over secant, and secant is equal to 1 over cosine. Then tangent is equal to 1 over cotangent, and then cotangent is equal to 1 over tangent. The quotient identities, the tangent is equal to sine over cosine. The cotangent is equal to cosine over sine. And then for Pythagorean identity, remember this is based upon the Pythagorean theorem, but it's also based on the unit circle. How if this is an xy coordinate and this hypotenuse is 1 and you make the right triangle, you have y and x. So you have x squared plus y squared equals 1. And remember, x is equal to the cosine, so you have cosine squared, plus y is equal to the sine, so you have sine squared equals 1. So that is one identity. Also, if you manipulate this by solving for the cosine squared, you have it's equal to 1 minus sine squared, and you also have sine squared is equal to 1 minus cosine squared. As far as other identities that come from this, if you divide this by x squared, you would get this is 1, and then y over x is tangent is equal to the secant squared, because 1 over x is secant. Likewise, if you took x squared plus y squared equals 1, and now you divide it by y squared, you would get x over y is cotangent, so you get cotangent squared plus 1 equals cosecant squared. So these are the Pythagorean identities. All right, so now using these to verify identities. For example, secant times cotangent equals cosecant. The first thing you want to do is change everything to sine and cosines. That's one method. For example, the secant is 1 over cosine. The cotangent is cosine over sine. And we're going to change the side that has the most stuff. So for example, the left-hand side here has the most stuff on it. It has 2 terms. Then we do some algebra. Well, 1 over cosine times cosine gives us 1 over sine. And then 1 over sine is equal to the cosecant, and if you notice, they are the same. So we verified the identity was true. If you look at the next one, doing the same thing, cosecant is 1 over sine. Tangent is sine over cosine. Notice you can cancel those out, so it becomes 1 over cosine, which is equal to the secant, and that's what we wanted to prove. Doing the same thing here, the left is more complicated. Well, tangent becomes sine over cosine. Well, sine times sine is sine squared. And remember, to add fractions, we get a common denominator. So you would have to multiply this by cosine. So you get sine squared over cosine plus cosine squared over cosine. Combine this and you get sine squared plus cosine squared over cosine. And notice sine squared plus cosine squared is 1 over cosine gives me secant, and that is what I wanted to prove. All right, cosine times cotangent. So this becomes cosine over sine. And then you can do the same thing. So now we have to get a common denominator. So it becomes cosine squared plus sine squared over sine squared. And then cosine squared plus sine squared is 1 over sine squared. Sorry, 1 over sine. No squared there. I made that up. So it becomes 1 over sine, which is equal to the cosecant. All right, using factoring to verify an identity. So for example here, this is cosine x minus cosine x sine x equals sine to the third. That's what we're doing here. So if you notice, on this side, both terms have a cosine, so we could factor it out. So we get 1 minus sorry, this should be right here. This should be a sine squared. So we get 1 minus sine squared All right, so let me fix this because I wrote this wrong in the beginning. So this should be a cosine to the third. So when you factor this cosine, you get cosine x times 1 minus sine squared equals cosine to the third. So 1 minus sine squared, as we found in our identities, is cosine squared. And then notice cosine times cosine is cosine to the third. So that would be the same. So let's try the next one. Let me write it correctly this time. So it's sine x minus sine x times cosine squared x equals sine to the third. Okay, so using the same thing here. If notice both of these have a sine, so we factor out the sine x and we get 1 minus cosine squared equals sine to the third, right? Equals that. 1 minus cosine squared is sine squared. And then sine squared times sine gives you sine to the third. And we verified the identity. All right. There's a couple different ways to do certain problems. For example, if I have this identity 1 plus sine x over cosine x equals secant x plus tangent x. So the first way is to take the left-hand side and see this single term quotient, separate it into two terms. For example, 1 plus sine of x could be 1 over cosine x plus sine over cosine x, like that. That's taking one quotient and separating it into two with the common denominator. Then from there, 1 over cosine x is the secant, and sine of x is the tangent. So notice we have proven it. Or if we worked with the other side, the second side here, we change it to sines and cosines. So we get 1 over cosine x plus sine over cosine. And then notice you get a common denominator, and it's 1 plus sine x over cosine x. So notice either side that we worked with in this case gave us the other one. So it didn't matter which side we chose, we could have gotten the correct answer. All right, we'll skip this one. Now, here are some guidelines for verifying the identity, so you can read them on your own. It talks about work with each side independently of the other, and starting with the more complicated first. Using everything in terms of sine and cosine, that we did that. We worked on factoring out the GCF. We talked about separating it into a quotient term into a single term into two, like for example, a plus b over c would equal a over c plus b over c. That's what we had talked about. And the one thing here is don't be afraid to stop and start over again if you're not getting anywhere. All right? If you struggle with it, just start over and try again. Don't just give up. All right. Part 2 of this video here, we'll talk about how to do trigonometric equations. So first thing here, to solve a trigonometric equation, we want to isolate the variable, on one side of the equation and then solve for it. So for example, 3 sine x minus 2 equals 5 sine x minus 1. So I'll subtract 3 sine x from both sides. So I get 2 sine x, and then I'll add 1. So 2 sine x equals negative 1. And then divide by 2. So I get negative 1/2 equals sine x. You could also put theta if you want. So now you have to figure out, well, where is the sine equal to negative 1/2? And the sine is equal to negative 1/2 in quadrant number 3 or 4. That's where it would be negative. And the sine is equal to 1/2. If you notice, 1, 2, if this is 30 degrees. 30 degrees is pi over 6. So if you move it around the quadrants, the third quadrant would mean that it is 7 pi over 6. And the fourth quadrant would mean that it is 11 pi over 6. Because if you think about it, in the third quadrant here, you go the reference angle plus pi, so pi plus pi over 6 gives you 7 pi. And in the fourth quadrant, you go 2 pi minus pi over 6, because it's 2 pi minus the reference angle, which is 11 pi over 6. So those are your two answers. Let's try another one. So here we go, 5 sine x equals 3 sine x plus the square root of 3. So we subtract 3 sine x from both sides. So you get 2 sine x equals the rad 3. So divide by 2, and you get sine x equals rad 3 over 2. So remember, this is going to be in quadrant 1 or 2 because the sign is positive in 1 or 2. So if you notice, rad 3 is the opposite 2, so this has to be 60, which is pi over 3. So in the first quadrant, the angle is just the reference angle, so it's pi over 3. In the second quadrant, it is pi minus pi over 3, which would be 2 pi over 3. So those are your two angles. All right, we're going to skip the next part and go to the last page, which talks about quadratics. So like, for example, 2 cosine squared x plus cosine x equals 1. And then to get it to be a quadratic, we set it equal to 0. So we go 2 cosine squared plus cosine minus 1 equals 0. And then we substitute. So we're going to say let y equal cosine x. So this is really 2y squared plus y minus 1 equals 0. So then you're going to have to factor. Well, what are the factors of negative 2 that add to 1? They are positive 2 and negative 1. So remember, it's going to be 2y plus 2, 2y minus 1. Well, if you divide this by 2, you get y plus 1. The common factor here is just 1, so it's going to stay 2y minus 1. And you solve this. So y plus 1 equals 0, 2y minus 1 equals 0, y equals negative 1, and in this case, y is going to equal 1/2. So y is the cosine, so the cosine x equals negative 1, cosine x equals 1/2. Now, where is the cosine equal to negative 1? That is at pi. If you look on the unit circle. Cosine x equals 1/2. Well, that's either quadrant 1 or 4. And if it's 1/2, remember, the cosine is 1/2. That means, this is rad 3, that means it's a 60-degree angle, or pi over 3. So that means x is equal to pi over 3 in the first. In the fourth quadrant, it's 2 pi minus pi over 3, which is going to be 5 pi over 3, because 2 times 3 is 6, so 6 minus 1 is 5 pi over 3. So those are the 3 answers that you get for this specific equation. All right, I hope that this has helped, and if you have any questions, please feel free to answer them or ask them in class. Have a good evening.